Afternoon to our customers out there, and today I'm talking to Steve Morton, who is our head of machining technology here at Anderson Global. And what we're going to be doing today is talk about how Anderson uses what's called an FCS system and some of the benefits of that. So good afternoon, Steve.
Hello, Mick. So our FCS clamping system is a configuration of clamping points on a plate that are used for both precision locators and clamping of parts. The main grid consists of a 50 millimeter grid with M16 threads and counterbores of 24 millimeters. Every machine in our facility has with a main table or a pallet, and we retro each machine with an FCS base plate with that same standard grid on it. Then what we'll do, the basic building component starts with what real estate you're working with. Sometimes there's restraints from the customer where we are not allowed to put FCS. So what we'll do is take that grid, transfer it to the part, and either put the FCS location in a location that will be machined away or will not affect function of the final part.
Okay, so that's an important thing to point out there, I think. So you're saying is depending on the product and the customer's preferences, we're going to ask for potential places where we can put this FCS system, and so that's a back and forth dialogue with the customer as to where we can do that.
Correct.
And in some cases, it'll be retained in the mold going forward. In some cases, we'll position it so it can be machined off if that's the preference.
Correct. And if putting the FCS directly into the part, topside, backsides, or perimeters is often ideal, but in the cases where it's not allowed, which are several customers and parts, that is true, we'll find another way, which is fixtures, still modular to the FCS, but we'll come up with rails or fixtures and or posts if the material allows for it. So one way or another, we'll get FCS into the part and to be able to machine and work cold more efficiently.
Okay, let's dive into what the actual FCS system looks like at the ground level.
It all begins with a standard ring, which is a 24 millimeter ring, and these are both precision locations and clamping locations. In most parts, they're used for, one is typically an origin, one is an alignment, and two are work holding clamping, so that we can pinpoint one FCS location to chase it from top side to the back side and maintain that relativity. Next is a FCS rod, which is M16 thread. These files are simplified, but there's threads on these rods on both ends. This end will work its way into a standard FCS component. This is one of many components. This is an 80 millimeter tall puck with threads on the inside. Most of the components are built with standard heights so that they're modular and they adapt.
So how does that puck clamp to the device then?
What we have is our files are simplified for being lightweight for real world manufacturing, but there are patented designs in the FCS that allow for a torque wrench in a couple turns to tighten up those rods into these bodies. We'll go back to the example part. Most precision parts that we manufacture require multiple flips or heat treat. What they've allowed us to do is work with pre-hard or after-hard rings, two different diameters. In this case, we worked with a 22 and a 24 millimeter ring for pre-hard and then after-hard, or for roughing and for finishing. Every time we flip the part, open it up until we finally get to the point where this ring is finished with the backside or the top side operations. That would be FCS in its very simplest form.
Okay, great. So now what's some real world applications that you can show us?
So this would be an example of a very simple mold, and working with our design, our CAM, our machine operators, all the way through CM. This would be a typical stack up of a part that we would get in CAM. And everybody's on the same page with this FCS. We know where the part is, we can simulate it, we can verify tool lengths, machine collisions, feature recognition. What we do is have one part for data management and then double up all of the setups for each operation. We would often start with in this case, applied block of material that's been prepped for us. And then we would take this part, very first op, put it in a set of vices. And in this case, this is an example of these four locations are not on our standard grid, but we found real estate in this part to put FCS in a non-standard grid. So we'll put FCS in this part temporarily. So these green surfaces are temp FCS posts is what we refer to them as. So the very first operation, this part would go into a vise and off of a drawing. They would skim this part and put FCS in these locations that will temporarily be used on the next operation and will eventually be removed. The next operation would go to the back side and go on FCS. So now we know where the part is, we know how high it is, we know the finished stock, we trust everything about this. So now, in this case, we would rough and finish this backside, including this perimeter, in one operation. This would be verified in the CAM machine simulation, where this operation used to be multiple operations, and we'd have to adjust toe clamps, and if the toe clamps were too tall or not in the right spot, we'd have programmer-operator conflict or run into them or not lit high enough. All those good variables have been removed. We would finish this back side and then flip it over again, potentially on another machine, a different unique machine, and then use FCS that we had just placed in the backside.
Yeah, of course, the advantage that you're mentioning there, Steve, is when you make those kind of moves from machine to machine, it's quick, isn't it?
It's very quick. The setup time used to be so inefficient that we used to try to do as many operations as possible on the same machine, even if it wasn't the right machine. That was 10, 15 years ago. Now with the implementation of FCS and the efficiency of it, we're allowed to actually run each operation on the appropriate machine, even if it's another setup. So in some cases, we've often doubled setups, but we're more efficient because we're on the right machinery now. Mm-hmm. And then there also used to be high risk of moving a part. Every time it went back on the machine, it was a manual pickup. With a big one was transposing of numbers. A lot of that information in those part-specific absolutes were X, Y's, and Z's four-place numbers that were often transposed, either on the setup sheets or by the operator typing them in when the part was being picked up. A lot of that has been removed, and we're more efficient. So in this case, this is our second. This would be a topside rough. These green surfaces are temporary. We would semi and finish this top side. This is a case where we've got perimeter keys that need to be done on a 4th-axis machine or a 5-axis machine. So this is where it gives us lots of choices, whether horizontal is available or we go to a 5-axis. But either way, this FCS has helped standardize when we're tipping and turning or coming across the table on these parts from 90 degrees. Before, the stack-ups weren't high enough for our programmers to clear spindles. With the standardization of the FCS, all of our horizontal and 5-axis parts are standardized for a special operation where they're a minimum of 160 millimeters high, which clears just about every spindle in the shop turned 90 degrees. So that's why we're representing 3 different setups. Temp posts, because these were used for the very first op. But in this particular case, the customer does not allow FCS on the top side, but they will allow us to find the real estate to put FCS in the backside. And in some cases, we will make plugs and plug them, or in some cases, we'll plug and even weld them. But what we're finding as we work with new customers, even customers that have been reluctant in the past to allow us to put any sort of feature into their part, once they get used to and allow us to do this, we're finding that they appreciate and it helps them in their facilities as well as ours for setups and revisions and rework and what have you. Another pro to this is our setup sheets have gotten much simpler. Oftentimes in the mold pattern world, every part had its own absolute that you could never lose, and you had to chase that back, which made no matter where it was located on the machine, the FCS allows us to, no matter what part is mounted to an FCS table, it's always referenced to the top center FCS location. So our setup sheet has gotten much simpler and lowered risk significantly on the floor.
Good, which is all helpful.
Another pro is outsourcing. Found more and more to companies that are using we're outsourcing facilities that also share FCS. We're building partnerships, sharing components, and when files and parts are shared between the companies, the risk is going down, and it's much simpler and easier than it used to be. Everybody's much more comfortable. And what we're finding is with this base FCS, there hasn't been a third-party work holding device that we have into yet, and we have several that we have not been able to get creative and adapt to the FCS. So we have a long laundry list of options for work holding, all of which have been with the assistance of third-party and or creative on our own that have not been adapted to FCS, so we know where they are. 3-jaw chucks, large vices, 0-point clamping systems, tombstones, risers, on and on and on.
Okay.
It will carry all this information right over into our simulation. This is an example of our Hermele C42 5-axis with a small aerospace part on a 0-point GRD clamp we've got various vice jaws that adapt to this. So this riser could be on a lathe, it could be on a 5-axis machine, it could be on a vertical machine, it could be on the EDM and or 5-axis, including CM. When we machine this part, we know exactly where this part is, no matter what machine it's on, because it's all off of X0, Y0, Z0 top center of this FCS palette. Setup sheets are simpler. When we simulate, there's no guessing. For years, our simulation was only as good as the tools, the holders, and the part location that we were simulating. What we received from design, what we simulate in CAM, and what was actually performed at the floor. If all 3 worlds weren't on the same page, the risk was high. With the implementation of FCS, design, our project leaders, our CAM, machine operators, are all on the same page, which ties us all together. And simulation, we can trust that this is in the right spot. And when we simulate and know that this tool path clears, we trust that it's going to clear when it's running unattended with nobody around.
That helps our lights out machining capability.
Correct.
Okay, Steve, I want to thank you for your time. I think that was a good introduction to FCS and how we do it at Anderson Global. Thanks a lot.
Thank you.